Okay, we're going to do some work on algebraic fractions, and specifically we're going to look at adding, subtracting, multiplying and dividing algebraic fractions. So algebraic fractions meaning that it's just going to be fractions with some letters as well as numbers in them. Just a quick recap, remember for adding fractions that we use the kiss and smile method, so that would be 1 times 3 is 3, plus 2 times 2 is 4, over 2 times 3 is 6, 7 over 6. If we had 3/5 take away 1/2, that would be 3 times 2 is 6, minus 1 times 5 is 5, over 5 times 2 is 10, so that would be 1 over 10. And if we had something like 3/4 multiplied by 2/3, so for multiplication it's not kiss and smile, you just multiply top and bottom, so 3 times 2 is 6, over 4 times 2 is 12, and then that can be simplified. 6 over 12 would come down to 1/2. And then we've looked at ones where you're dividing a fraction by another fraction, so you change your divide into a multiply, flip the second fraction upside down, and that would be 12 over 15, top and bottom by 3, and that would give me 4 over 5. Okay, so for algebraic fractions we're going to follow a lot of those rules as well, but apply them with letters and numbers. And let's look at example 1. Okay, example 1, we've got p over 6 plus 2p over 3. So start at the top left hand side, p times 3 is 3p, plus 2p times 6 is 12p, over 6 times 3 is 18. Let's tidy up the top, 3p plus 12p is 15p, 15p over 18. Okay, so for 15 and 18 we can simplify that, so the biggest factor of 15 and 18 is 3, so we can divide top and bottom by 3, 15p divided by 3 will be 5p, 18 divided by 3 is 6, final answer 5p over 6. Let's just go over that again. So we're adding, so we're going to look at kiss and smile, so there's the kiss, there's a smile, so p times 3 is 3p, plus 2p times 6 is 12p, over 6 times 3 is 18. 3p plus 12p, gather them together to get 15p, 15p over 18. And then I can divide top and bottom by 3, gives me 5p over 6. Okay, let's take down example 2. Okay, so we've got 2 over a plus 5 over 2a. Okay, so we're adding fractions, so kiss and smile again. 2 times 2a is 4a, plus 5 times a is 5a, over a times 2a, a times 2a, so that's going to be 2a squared. Okay, 4a plus 5a is 9a, so I've got 9a over 2a squared. Okay, now think about 9a over 2a squared, that's the same as 9a over 2a times a. So what we can do there is cancel out, and that will give us 9 over 2a. So the a cancels out with, brings that square down to leave us with 9 over 2a. Okay, example 3. Okay, example 3, let's go for 5 over x plus 3 over y. Okay, kiss and smile again. 5 times y is 5y, plus 3 times x is 3x, over x times y is xy. 5y plus 3x, well x's and y's are not like terms, so that's as simple as that goes. Final answer 5y plus 3x over xy. Let's take down example 4. Example 4, 3 over 2x plus 2 over 3y. Okay, kiss and smile, starting at the top left hand side. 3 lots of 3y is 9y, plus 2 lots of 2x is 4x, over 2x times 3y, well 2 times 3 is 6, and x times y is xy. Okay, I can't collect those y's and x's together, that's the final answer. Example 5. Okay, so I've got 7 over 3p plus 2 over 6q. Okay, kiss and smile, 7 times 6q is 42q, plus 2 times 3p is 6p over 3p times 6q. Well, 3 times 6 is 18. pk times q is pq. Okay, so what you'll notice from these ones up here is I couldn't collect together terms there, and there was also not a common factor to take out. And I can't collect terms here, but I can take out a highest common factor, which will allow me to simplify this one further. So 42q plus 6p, well, I can take out a common factor there of 6. So it's going to be 6 bracket 7q. 6 times 7q is 42q. So 6 bracket 7q plus p over 18pq. Okay, now that's 6 over 18. That can then cancel down to 1/3. So that will be 1 lot of 7p plus q over 3pq. I don't need the bracket there. I can just write that as 7p plus q over 3pq. Okay, let's try an example 6. 8 over 2m plus 5 over 3m squared. Okay, kiss and smile. Start top left hand side. 8 lots of 3m squared is 24m squared. 5 lots of 2m is 10m over 2m times 3m squared. Well, 2 times 3 is 6, and m times m squared is m cubed. Okay, so I can't collect terms together at the top, but I can definitely take out a highest common factor, so I take as much as possible. From 24 and 10, I can take 2, but I can also take m. So 2m times what gives me 24m squared. Well, 2 up to 24 is 12, and m up to m squared is m 12m. 2m up to 10m, well, that's 5 over 6m cubed. Okay, the 2 over 6, that can now cancel down to 1/3, and that m will cancel out with one of the m's there to bring that down to m squared. So think about that as you've got m over m times m times m. Cancel 1 from the top and the bottom, gives you m squared down there. Okay, so that will give me 1 lot of 12m plus 5 is just 12m plus 5 over 3m squared, final answer. Okay, example 7. 5p over 6, I'm subtracting this time. 5p over 6 minus 2p over 3. Okay, so for addition and subtraction, it's still kiss and smile. Always start at the top left hand side. 5p times 3 is 15p minus 2p times 6 is 12p over 6 times 3 is 18. 15p take away 12p is 3p. 3p over 18. Okay, I can divide top and bottom by 3 there, and that will give me p over 6. Final answer. Let's take down example 8. Okay, 5 over a minus 1 over 2a. 5 lots of 2a is 10a minus 1 lot of a is a over a times 2a is 2a squared. 10a would take away a is 9a, 9a over 2a squared. Okay, so think about that. That's 9a over 2 times a times a. I can cancel 1 from top and bottom, and that will give me 9 over 2a. Final answer. Okay, example 9. 5 over x minus 3 over y. Start at the top left hand side, kiss and smile. 5 times y is 5y minus 3 times x is 3x. Over x times y is xy. Can I factorise the top? No, I can't. Final answer. Example 10. Example 10, and we've got 3 over 2x minus 2 over 3y. Kiss and smile. Start at the top left hand side. 3 times 3y is 9y. Minus 2 times 2x is 4x. Over 2x times 3y. Well, 2 times 3 is 6. And x times y is xy. Okay, can I factorise the top? No, I can't. Can't collect like terms either. Final answer. Okay, example 11. 7 over 3p minus 2 over 6q. Okay, so we're subtracting kiss and smile to start the top left hand side. 7 lots of 6q's, 42q minus 2 lots of 3p is 6p. Over 3p times 6q, well 3 times 6 is 18, and p times q is pq. Okay, so can I factorise the top? Yeah, I can. So I can take out a highest common factor there as 6. 6 brackets 7q minus p over 18pq. That's 6 over 18 can cancel down. Well, we can divide top and bottom by 6 there, which will bring that down to 1/3. So that's 1 lot of 7p minus q is 7p minus q over 3pq. So what I did there was, after taking out the common factor of 6, I identified that 6 over 18 could come down to 1/3. So 1 lot of the bracket is just the term inside the bracket over 3pq. Okay, example 12. And we've got 7 over 2p squared minus 4 over 3p. Okay, kiss and smile. 7 lots of 3p's, 21p minus 4 times 2p squared is 8p squared over 2p squared times 3p. 2 times 3 is 6, and p squared times p is p cubed. Okay, so I can't collect like terms here, but I can absolutely take out a common factor. So for 21 and 8, I can't take anything, but I can definitely take out a common factor of p. So it's going to be p bracket 21 minus 8p over 6p cubed. Okay, I can now cancel that p, which will bring that p cubed down to p squared, which gives me a final answer of 21 minus 8p over 6p squared, final answer.